Good. First, let's modify something in the Simon Says function, because now it plays just the complete sentence, and actually I want to make sure that each time it plays a longer sentence or a longer part of the sentence. So I will add a variable for that, and I will call that the current length of the sentence. I will make that 0. And this is a variable that I'm going to use, because actually I only want to talk. I only want to go forward into the position if we are smaller than the current length. So if I say, like in this case, if the position in sentence is smaller than the current length of the sentence, then I would like to update it. And otherwise, I actually just want to say that, what else do I want to say? Actually, if I reach the end of the current length of the sentence, then I want to give the turn to the user, because in that way the user can repeat the sentence. But this one I can comment right now. Maybe I use it later. So let's see what Simon does right now. And that's indeed the right behavior, because it just stays in this the position stays like this because the current length of the sentence is longer. So when do I update this current length of the sentence? Well, actually Simon makes the sentence longer when the user repeated his first word good, and then he adds 2 words and then 3 words. So that has to be done in the user state. And here I mentioned already one element. That's the use of states, because we have kind of a dialogue between Simon and the user. So sometimes it's we start with Simon's turn, then it's the user's turn to repeat Simon in a good way, then it's Simon's turn again, then it's the user's turn. So we have that back and forth thing. So I will add a boolean for that, and I will call that Simon's turn. Boolean is Simon's turn is false. Yeah, I don't know if it's false, if that's, no, let's start it not with false, let's start it with true in this case. So if Simon's turn, if it's Simon's turn, then do the Simon thinks talk. And on the moment that I set my sentence, I want to give the turn to the user. So I can say, like, well, make is Simon's turn, make that false. Is Simon's turn is false. And one thing what I have to do then as well, because I give the turn to the user, made a typo, I want to change the position in the sentence back to 0, because the user needs to repeat the whole sentence. So is Simon's turn is false. So let's see what happens right now. Okay, Simon plays a note, and I hope that I have now the user turn, so I can press now also something. Yeah, and this is a wrong error, and this one is also wrong, because now I have to press 3. Now it generates already a new sentence, so that's when we have to give the turn back to Simon. and this is good, 1, and then I expect to go to 3, and then to 1. But now I stay in the user state and the sentence doesn't get any longer. So what I want to do is like, okay, on the moment that I give a good answer, if my answer is good, I don't go directly to the next position in the sentence. No, I have to make the sentence longer and the turn goes back to Simon. So that is what I'm going to program right now. So we have kind of the same system. If the current length, or if the position in the sentence is smaller than the current length of the sentence, if that is the case, I can move forward. But if we reach the length of the sentence, so if we set the sentence, good, because if it's wrong, we already make a new sentence. So if we set it good, we can say like, well, we want to start. Let Simon start again with a new sentence. So we can say like, well, else. We can say like, okay, make the current length of the sentence 1 longer, like this, and again change the position in the sentence to 0, because it has to go backward, because Simon has to say again the sentence. And I can say like, well, okay, now it's Simon's turn again. Is Simon's turn is true. And maybe it's also smart to do an extra step to add another if statement, because actually we don't want to respond on mouse clicks when Simon is talking. So what I will do, I will say here, if is Simon turn is equal to false, then I can execute this part of the code. So we get a lot of if statements here, but it's, well, we can make it in a function if we want. And I will do the same with the mouse pressed function. Remove this. Okay, so now let's see if something happens. Okay. That kind of works. The sentence gets longer each time. The only thing is that Simon seems like a bit impatient, because he starts directly talking, and that's not what we want, of course. So we can use the timeout variable for that, because actually the timeout variable is like, okay, if Melis is bigger than a certain timeout, then Simon starts to talk. So we use the timeout over here. But of course we can use the timeout also after we released the button. So that's what we are going to do. We say like, okay, make the timeout millis, and we can say like, well, let's make that Simon waits for 1 second, and then he starts making the new sentence again. So let's see how that works. Okay, Simon says. Etc. So that that works, that timeout. Well, there's one thing we can go on now. The problem is like we don't have a check built in if we won, because actually, if we reach the complete length of the sentence, then we won the game. So I can program that if the current length of the sentence is equal to Simon sentence dot length and then -1, 31. Yeah, otherwise we get again an out of bounds error. Then I can say like, well, print line, and I can say the user wins. And else we will do what we already programmed. Like this. There's a typo here. Current length of the sentence. So the user wins. Well, I'm a bit impatient. I don't want to finish the whole game. So what I do, I just make the game a bit shorter. I only have a sentence of 2 tones. So, okay, 1, 1, 1. Woo! I won the game! Yay! Okay, that was a hard thing to beat. Of course, when I win the game, I want to start over again. So that's one thing I program. Let's see what happens if I lose. And it makes a new sentence. And if I lose, it doesn't start speaking again. So that's also one thing. Yeah? So it makes now a sentence, a new sentence. If I see it right, press 2. And now I expect that Simon starts talking the new sentence, and it doesn't do that. We have to make sure that Simon starts again talking. So let's see where it was wrong. Said like, okay, make a new sentence, and I can say like, well, also make sure that it's Simon's turn. So is Simon's turn is true. And the same goes for, actually, if the user wins, we need to do something as well. But let's first try this one. So that works. It starts over again, but again, we need to provide a timeout. Well, now I have multiple positions where we can restart Simon. We will restart it over here. We will restart it over here, because if we win, we also want to restart the game. So I will make a function called Simon starts new game. Used to group everything, and I will call the make new sentence from that, because always with a new game I have a new sentence, and I want to start with a timeout. Is millis plus 1000, and of course when we start a new game it's directly Simon's turn. So like this, and so Simon starts a new game. So at which point we have to start a new game? Well, in this case over here. No, in that case not, because this one is just the normal wait, and we don't have to start a new game. In this case we have to start a new game. And in this case, when we are wrong, we have to start a new game. And actually what I will do, I will also start a new game when we are starting up our program. And the nice thing is that also now, because we have that timeout programmed, Simon waits 1 second. So when we press play, we have 1 second and then Simon starts playing. So let's see what happens right now. 1 note. And now something strange happens because it triggers 2 times 1-1 already, while it actually should start with 1 note playing back. So this seems to work good. Let's see if I can see it again. Yeah, it waits, then I press. And then I press, for example, a wrong note. And now it gives me directly 2 tones instead of 1 tone. So let's see what that does, because the position in the sentence is only displayed over here. So maybe I can just do a print line over here. Position in sentence. Position in sentence. So before we start. And let's also check the current length of the sentence. Okay, so now the position in the sentence is 0 and the current length is 0. So I press this one. Now the current length is 1 and the position is 1. And now the current length is still 1. So the current length stays 1 all the time. I can see if I can change this a bit, because now I have the array really short, so I'll make it again the length as it was originally. Yeah, it plays directly a longer sentence, so you see now it's even more obvious. The length stays the same. So what I also have to do, if I start a new game, I have to make sure that the length of the sentence is, of course, that we reset it. So I can do that in the start a new game. Now I can do that when I make a new sentence here. This is more logical. Position in sentence is 0 and the current length of the sentence has to become 0. So let's see what happens right now. Okay, current length is 2. It's 3. Now I make a wrong note. And the current length gets 0 again. Yeah, that's what the behavior we would like to see. Let me see. So I can remove this again. I'm done with debugging that. Okay, so we have kind of the Simon game now programmed. Because the user wins, we can start a new game. The position of the center is taken care of. We have the waiting. One thing we have to program still is the speed of talking. Because if Simon says a longer sentence, he needs to able to talk faster. So at the point where I make the length of the sentence, I can also say, like, well, make sure that we modify the talk time, because actually if we look here, we can see that if the length is lower than 6, then it needs to be 420 seconds, then lower than 14, 320 milliseconds, and then the rest of the tones should be 220. So let's see if I can program that. If the current length of the sentence is smaller than 6, and in this case I need to use a variable, because now it's still I think a fixed number. Let's see. Yeah, it's a fixed number. It's 420. So I need to make a variable of that. So I will call it, for example, talk time, and then I will also add that to my program. Int talk time. Well, by default it's 420. And let's see. And here, this one is also 420. This uses also the talk time. So Simon, for Simon, we all the time use the talk time, and that talk time gets modified. For the user, we just keep it 420 and the wrong note as well, because that's really clear. The user shouldn't, that tone doesn't need to become shorter or something. So if the current length of the sentence is smaller than 6, actually the talk time is 420, else if the current length of the sentence is smaller than 14, we make the talk time 320, and else the talk time is 220. So, okay, so Simon starts to talk faster after a while. Okay, to see if this works, I will make the time a bit shorter, because more than 6 good and 14 good, that doesn't work really good. So just smaller than 2, smaller than 4, and I will do also a print line, talk time, talk time, just to visualize what's going on. Yeah, see, it worked. So it went faster and faster. You can see the talk time here becoming faster. Revert these steps. So this is programmed. Well, one extra thing what I would like to do is I want to give some visual feedback, so we know when it's our turn and when it's a turn for Simon. So I can make sure that I print the text. I can say like, okay, if is Simon's turn, do something else, then it's the user's turn, and I will say like, okay, text is Simon's turn, and I will place this text in the middle. And otherwise I will say like, well, make it your turn, width and height divided by 2. So that's nice in the middle. Let's see if that works. Yeah, it works, but really small, and the color is not so nice. So I will say that I will make the color white. And I want the text to become bigger, so the text size needs to be 40, and the text alignment, text align, I put that in the center and in the center. These commands, I just know them now, but you can look them up, of course, in the processing reference. So let's see how that works. my turn, Simon's turn, Simon's turn. Yeah, so that switch is nice. Of course, this is a setting that is all the time the same for text. So I can actually say like, okay, I put this into the setup function. So I have this fill. And what I can do now, it starts directly with Simon's turn. I can also say like, well, it's maybe nice to give a message that Simon starts. Well, one thing to do is like, okay, if the length of the sentence is 0 and if it's Simon's turn, then we are at the start of the sentence. So if the current length of the sentence is equal to 0, then print text, and then I say Simon starts, else I will print the text and that says Simon's turn. This one I don't need anymore. Oh, don't delete too much. This. Okay, Simon starts. Okay, and that's it. And of course I can turn off some print lines that I still have active. Print line because released here the position in the sentence. So I have also always this line in the console, so I can just peek and play the game because I know the sentence already. So this is my little cheat code. Okay, I think that's about it. We programmed a basic version of Simon. And the next step can be that you add multiple states. So for example, that you wait when clicking the game. You can also say like, okay, I implement a winning state. What might be nice, because otherwise it's now it just starts over, just prints winning in the console. That's a bit boring. So the reason, we have now a Boolean that says like if it's Simon's turn is true and false. So we have actually, our program has two states. If you want to have multiple states, then you can make an integer, for example, and call it game state. And a game state can have a certain value. And a smart idea is to make it just a variable or a constant. So you can say like, okay, you can make an integer that says Simon's turn. Then that's 1. Int user's turn 1, 2. Int Simon wins is 3. Int user wins is 4, and like that you can have multiple states, and you can just set the game state to or to Simon's turn or to the user wins, and it's convenient to have a variable for that because you can just read it really easily in the code. And the reason that you write it with capitals is because it's a constant, so we never change the numbers during the program. So that's just one way to show that. But well, that's for another time to elaborate on that. Okay, thank you for watching.